Hi, okay, so today we're going to cover exercise 1.1. All right. Okay, so to begin with, before we cover exercise 1.1, these are the learning outcomes that I've gone through in class earlier. Okay, so let's look at example 1. Okay, example 1, they've given you ungrouped data. So when you have ungrouped data, you need to rearrange it from small to big. Then only you can do the question. Okay, so the first part of the question is ask you to calculate with the outlier. So in this case, your outlier is 30. Okay, so I'll just show you where are we in the manual. Here, right here. So find the mean, median, and mode for set X. So you're going to find the original value. They've already arranged for you from small to big. So your mean will be 7.8, your median will be 5, your mode will be 3, and your n is 15. N is the total number of data. Okay, then the part B told you if 30 is considered an outlier and is removed, find the new. So now you're going to find the new mean, mode, and median without the 30. So the new mean, mode, and median should decrease because you're taking out a big value. So your mean should reduce. Your median has changed not because of the outlier. Your median has changed because the total number of data has changed. You understand? The total number of data has changed. Meaning from 15 it became 14. So the position of the median has changed. Nothing to do with outlier. Okay, and in part C, if the score 30 was changed to 300, that means now 30 you're going to change to 300. Logically, what will happen to your mean? Logically, your mean will become bigger. Correct or not? Logically, your mean will become bigger. All right. So your new mean here will be 25.8, much bigger because you're adding a very big value. Your median will be the same because your n is the same, so your position of your median won't change. Okay, and then your mode will be 3 and your n will be 15. Now this last question here always comes out. What is the effect of outlier on MCT? MCT is mean, mode, median, so you must talk about all three. So big outlier, big mean. That means when outlier is big, you can use these arrows, I got no problem. So I want this answer. This is the standard answer. Big outlier, big mean. Small outlier, small mean. Meaning when your outlier is big, your mean will be big. Your outlier is small, your mean will also be small. Okay, outlier will pull the mean towards itself. Here you can see when the 30 was there, the mean is big. 30 take out, the mean becomes small. You put 300, the mean become even bigger. Mode and median, no effect. The median here changed because the number of data changed. Nothing to do with your outlier. Okay, next part. The weight of 42 broad beans. So this is example 2. Example 2, I would rather you just do it at your own time. It's very repetitive from semester 2. Okay, they've given you a table here. They want you to draw the histogram. So basically, this is what they want out of you. They want a histogram, and then they want you to calculate mean, median, and mode. So here you got to use these formulas. So don't worry, in your exams as well, formulas will be given again for semester 3. So you use your formula. Go back and revise how to use this formula. Please go back to semester 2. You will be using it again. So you're going to calculate your mean, median, and mode, meaning you need to have the extra columns called cumulative frequency and fx. Okay, so you need to have that 2 extra columns. So you find your mean, median, and mode, and you will notice that your mean, median, and mode is quite similar. When your mean, median, and mode is quite similar, your MCT is quite similar, you pretty much know it's a fairly symmetrical curve. It will never be all equal. If it's all equal, it's engineered data. It's not a normal data. They call it as a data that's been edited. Understand? All right. Okay, so your MCT is similar. Okay, so that's example 2. I will leave you to do it at your own time. So let's look at example 3. 6 sets of data are represented in the graphs below. By looking at the shape of the distribution, guess which. So now when you have the mean equal to the median, what does that tell you? When it is equal, you know it is almost normal, basically almost symmetrical. Okay, have the mean less than the median. Now I'm going back to what I taught you here. When your mean is big, meaning your outlier is big. Your mean is small, meaning your outlier is also small. Understand? Okay, so this is where I'm coming to now. All right, so I'm going to go back to the manual first. So if my mean is smaller than my median, meaning my mean is small. So if my mean is small, what does that tell you? Your outlier is small. Okay, here your mean is greater than your median, meaning my mean is big. What does that tell you? My outlier is big. All right, so I want you to put this in your head. If your mean is small, your outlier is small, because your mean will follow your outlier. Okay, I don't want you to memorize. There is a way to do it. You see, when you look at skewness, when it's skewed to the left, your outlier is small. That means your mean is smaller than your median. When you're skewed to the right, your outlier is big. But I don't want you to memorize like that. I don't want you to memorize. So let's take a look. So if you draw the curve for A, this is the curve, right? Where is most of the curve will look like that? Yes, it looks like it's skewed to the left, or it is negatively skewed. So what's happening? Where's most of your data? Most of your data is in the bigger end, right? If most of your data is in the bigger end, meaning your outlier is small. That means your outlier is small. If your outlier is small, your mean is less than your median. This is how I want you to do it. Okay? If most of your data is in the bigger end, that means your outlier is smaller. That means because most of your data is here, your concentration is here, so your outlier has to be in the opposite end. Okay, this one is very obvious. This is almost symmetrical, where your mean is equal to your median. Let's look at C. So if I draw the curve, it looks like that, right? That means most of my data is from minimum to Q3. 75% is from minimum to Q3. That means 75% of my data is small, meaning my outlier is big. Big outlier, big mean. So my mean is greater than my median. How about D? A lot of students will draw one mountain for me. Oh, go up and come down. Cannot. I've never taught you such a curve. So if you look at D, D looks symmetrical, correct? Whenever any two things is symmetrical, it will be equal. It will be almost normal. Your mean will be equal to your median. Okay, draw a curve for E. What do you see for E? Most of your data is on the bigger end, right? Because you see, it's skewed to the left, correct? It's negatively skewed. So 75% of your data is here, meaning your outlier is small. Outlier is small means mean is smaller than median. This one also you draw, it goes like that. So 75% of your data is here from minimum to Q3, which is small. So your outlier is big. If your outlier is big, your mean is greater than your median. All right? Okay, so basically this is how you get it done. I don't want you to memorize this. I will share the slides with you as well, but I don't want you to memorize it, because if you get it wrong, everything will be wrong. I don't want that to happen, okay? All right. So like I discussed earlier, so your mean, all of it is already matched here, okay? To confirm your guesses, calculate your mean and median for each. I don't think you need to do this. You need to calculate. I've calculated it for you here to prove that what you have matched is correct. All right, what you have matched is correct. So you don't need to calculate. I've done it for you. Are we good there? So this is important. You must know how to see the shape of the histogram and comment. Sometimes they don't give you numbers. You cannot calculate. So you need to look at the shape and you must learn how to comment. Oh, is my mean bigger or my median, or is my mean smaller than my median? So these sort of things you must know how to comment. Okay, so let's look at exercise 1.1. Number 1 and 2, I will leave you to do it at your own time. Okay, it's very much similar. Calculate your mean. Okay, you can get it done now. Pause the video and just get it done. This is all direct stuff. Same here, calculate the median for each set. You arrange from small to big. N plus 1 divided by 2. Find the position and write it down. Okay, make sure you arrange from small to big. Some are already arranged, some are not. Okay, I think the first two are sort of arranged already. All right, the others you need to arrange it, then you calculate. So let's look at question 3. A biology student was doing an experiment. She took the following meter readings. Find the mean, median, or mode of these readings. So you arrange from small to big first. This will be the mean, median, and mode. Okay. She later then decided 30 was an outlier. So you remove the 30. You can see your mean will decrease. Median and mode will stay the same. Okay. median and mode will stay the same. Which of these three statistics is distorted most by an outlier? Which will be most distorted? Okay, is usually the mean. Okay, if you don't want to write so much like this, you can just put this. Big outlier, big mean. Outlier remove, mean will reduce. Okay, you can write like that. It's the same thing. You can use these arrows instead of writing it as full. Okay, so your mean is the one always distorted by the outlier. Okay, question 4. A store can only order a particular brand of shoe in only one size. To decide which size she should order, the manager looks at the statistics for sales of that particular brand for the previous year. She should order the mean, median, or model size. So which one? So you always order the one that is sold the most, which is the mode. Model is mode. So you order the one that is the model, which is of the highest frequency. All right. Okay, question 5. Okay, so question 5 is like this. So they've given you the values here. Find the mean, median, or mode. So now this is ungroup. You need to rearrange it from small to big. Rearrange from small to big first. Find your original mean, median, and mode first. Okay? After you find your original mean, median, and mode, then they say 3.21 is an outlier. Even so, including the outlier, which of the three measures is the best indicator? So usually for measuring performance, even for your results or for running or for performance of a car, we usually use average. Okay, we usually use average. But in this case, there is outlier. Okay, so this will be your answer. The mean is usually the best indicator of overall performance without the presence of outlier. So if there is an outlier, the mean is no longer valid as it may be distorted by the outlier. Okay, so this will be your answer. Basically, there is no, you see, if the mean is distorted, you can use the mode. But in this case, there is no mode. So you can't even use the mode because there is no mode. The median is just the middle. The median doesn't tell you anything. Understand? So usually the mean is the best indicator. But now that the mean is not valid, you cannot use it. So basically, there is that you will fall for the mode next, but there is no mode. So basically, this will be your answer. All right? This part will be your answer. So you pause it and write it down. Okay? Now, to find the valid average. So what I want you to do is here, look at the word valid. This is a value, this is a word always ignored by students. The word valid means basically justified, that means correct. Okay, so now here they already told you omit the outlier. In your exam, they won't tell you. They'll just ask you calculate valid, mean, and standard deviation. Students always ignore the word valid. I don't know why. So whenever you see the word valid, you need to remove outlier. Understand? So you take out the 3.21 and calculate the new mean and describe it. So when you remove it, the new mean will be 10.33 seconds, which is the best indicator for overall performance after you remove. Okay, so the effect of outlier, small mean, small outlier, small mean. When outlier remove, mean will increase. Understand? See, when outlier remove, mean will increase. Just stick to that same standard answer all the time. Okay? So number 6 as well, I will leave you to do it. You can pause the video, get it done. Okay, the answers are also shared with you already. I also put the answers here. Pause it, get it done. All right. Okay, it's just mean, mode, median is the same thing. It's group data without intervals. Add your extra column for FX and CF and get it done. Please do it. A lot of students have forgotten how to do it because you will still use this knowledge. If you don't know how to do this, it's going to be a problem. So while you're doing it, let's say you have a problem, you don't know how to do, just reach out to me. I will help you. Okay? So let's look at question 7. Same like what I taught you just now. 3 frequency ABC match. So now this one, mean is smaller than median. So let's do the easiest first, the one that is all equal, which will be this, right? This is symmetrical, so mean, mode, median is equal. So C and C match to each other. So the first one, mean is less than median. When you have mean less than median, what does that tell you? Your outlier is small, correct or not? So in this case, right, my outlier must be small. Correct or not? So if my outlier is small, Meaning, let's take a look at this. If I draw this, most of my data is in the smaller end. My outlier is big, so cannot be this. I draw this, skewed to the left, negatively skewed. My outlier is small, right? Because most of my data is big, my outlier is small. So if my outlier is small, my mean will be smaller than median. So this part matches to histogram B. Understand? So part A matches to histogram B. And part B, the mean is bigger than the median. Here my outlier is big. So this is for part A. Alright, so use the same knowledge I taught you earlier. Shouldn't be a problem. Number 8. Okay, they've given you this data. So you add up everything. Plus x, divide with the total number, equal to 10. You solve it to find x. Cross multiply. Okay, don't know how to do, please reach out. This one is easy. You just add up all. So you add up, you get one whole number plus x over the total number of data here equals to 15.6. Cross multiply, you will find the answer. Okay, these are the answers: 13, 16.4 and negative 25. You should be able to get it. Okay, moving forward, question 9. I'll just go through the questions. You pause and play as you're going along, all right? Okay, during the rush hour, 56 trains, each carrying an average of 251 passengers, leave the platform. That means that's the first hour. The remaining 23 hours, 70 trains, each carrying an average of 69, depart. So trains leaving per hour is always the total number of trains divide with the total number of hours. You just follow the phrase. So total number of trains is 56 plus 70, divide with the total number of hours, which is 24. Sorry, I don't know where this came from. 24, you will get 5.25. You have to round off to the nearest whole number because it is train. You cannot have decimal place. Be approximately 5 trains. Passengers per train, total number of passengers, divide with total number of trains. Okay, total number of passengers, divide with total number of trains. So you 56 times 251 plus 70 times 69 over total number of trains, which is 126, will give you 150. Okay, 149.9, nearest whole number, 150. In a company, okay, so you pause, get it done, then play and continue, okay? In a company, 5 supervisors are paid 33,000. So you put it into a table, easier for you to see. 20 trainees are paid 25,400. Calculate the mean combined. So 5 times 33,000 plus 20 times this, divide by 25. Total number 25. You will get this. One of the supervisor leaves the company and is not replaced. That means one supervisor is going, not replaced. The manager decided that the total salary does not increase, so the trainees can have a pay rise. Meaning now there is an extra 33,000. The supervisor leaving, there is an extra 33,000 which is giving to the trainees. There are how many trainees? 20. So 33,000 you divide with 20. That means each trainee will get an extra of 1650. So you take the original salary of 25,400 plus 1650, you get 27,050. Okay? That is the new annual salary. Now, by how much will the combined mean change? You have to find the new combined mean first. So initially was 5, now become 4, 33,000. 20 initially was only this much. Now they got a salary raise to 75050. However, you calculate this, you calculate your new combined mean, then you minus these two values to find the difference. Okay, so you should be able to manage this. Pause it, follow the video, play. Okay, last one here, they've already given you a table. On average, how much per hour would each 4 worker would be paid? So you find the total salary first here. Okay, so you can see I've actually made the table a little bigger for you. So you got number and hourly rate. I've increased here the 8 hours, which is from this part actually. All right, then the total salary. So 118,156, you divide with 26. How much per hour? So total money over total number of hours. How much per hour? That means total hours is 26. Because 1 and 2 work 8 hours and level 3 work 10 hours. So you get 18.67. What would be the median hourly rate? What's median? Middle. What's middle? N plus 1 divided by 2. 46 divided by 2 is 23. So data number 23 sits inside here, which is 19.5. Okay, which is 19.5. All right, which is 19.5. Okay, if workers on level 1 and 2 work 8 hours and 3 works 10 hours, so now you're calculating the total salary altogether. So you take 6. So calculate the mean wage per floor worker. So total wage salary divide with 45. Number of floor workers, you will get 155.41. Okay, so today we will stop at exercise 1.1. All right, just pause and play as you go along. Any questions? So we follow the same way. Once you're done, upload your work. Any questions, just reach out. All right.